What if I told you there's a part of the moon we've never truly touched, hidden from Earth's gaze for billions of years? China just cracked open this enigma, and what they found changes everything. Stay with us to uncover the stunning secrets of the far side, a place shielded from Earth's influence and holding clues to the very formation of our solar system. For centuries, one side of the moon has been like a locked door we couldn't open, while the near side, the one we always see, has been studied, mapped, and even walked on. The far side remained elusive, a hidden expanse facing permanently away from Earth. Even though it's bathed in sunlight just like the side we know, the far side earned the nickname the dark side because it stayed shrouded in mystery, untouchable and unreachable for most of human history. A world so close to us, yet entirely out of our grasp. So, what makes the far side so different? To start, the moon is tidally locked, meaning the same side always faces Earth while the far side stays forever turned away. The near side is dotted with smooth, dark plains called Maria, created from ancient volcanic activity. In contrast, images of the far side reveal an almost alien landscape, a dense thicket of craters and rugged highlands, with hardly any Maria in sight. Early scientists were baffled by these differences. What could cause one side to be so scarred and mountainous, while the other, comparatively, seemed calm and flat? It's a question that has intrigued researchers for decades. When NASA began its race to the moon in the 1960s, conquering the far side wasn't even on the table. The Apollo missions focused on the equatorial, near side, where astronauts could land with fewer risks and maintain direct communication with Earth. That last part was critical because the far side is completely cut off from Earth's radio signals. It meant no spacecraft could phone home on its own. This communication barrier, combined with unpredictable terrain and a lack of advanced technology at the time, made the far side an impossible target. Astronauts Neil Armstrong and Buzz Aldrin may have left historic footprints on the moon, but they stayed far away from this untamed region. Apollo 8, the first crewed spacecraft to orbit the moon, gave humanity its first close-up views of the far side. But even then, no plans were made to land there. It was simply too risky. As groundbreaking as NASA's missions were, much of the moon was left untouched. Scientists had to rely on photographs and remote sensing to guess what conditions might be like. But images can only tell you so much. What was the geology of the far side? What secrets might be buried in its soil? These were questions that couldn't be answered back then. Yet, scientifically, the far side offered something extraordinary. It's completely shielded from Earth's electromagnetic interference. That makes it the perfect location for studying cosmic phenomena like faint radio waves from the early universe, signals that get drowned out on Earth and even on the near side of the moon. Additionally, because the far side remains geologically pristine, untouched by the same level of volcanic activity that shaped the near side, it preserves a more ancient record of lunar history. Fragments from asteroid impacts, layers of untouched regolith, and even remnants of the moon's formation are likely hidden beneath its rugged surface. Exploring the far side wasn't just about proving technological prowess. It was about unlocking billions of years of planetary history, a time capsule waiting to be opened. But for decades, no one dared. The far side remained a challenge that astronomers and engineers couldn't yet solve. Until now. While nations like the US and the Soviet Union had set their sights closer to home, China was quietly preparing for something bigger. Through their Chang'e lunar program, China was making bold moves to explore the moon, steadily increasing the scope of each mission. Named after the Chinese goddess of the moon, the program began testing the waters with a series of orbiters and rovers, tackling challenges one step at a time. By the time Chang'e 4 launched in 2018, it was clear they were aiming for something no one else had achieved. Why take on the far side? For China, the reasons were both scientific and strategic. Scientifically, the untouched terrain of the far side represented a wealth of untapped data. But strategically, it was also about proving their growing capabilities in space exploration. Landing there showed the world that China wasn't just catching up to other spacefaring nations, it was forging a new path entirely. The Chang'e 4 mission, which successfully landed in the moon's von Karman crater, marked the first time a spacecraft touched the far side. It was a moment that shifted the landscape of lunar exploration, with a rover named U2 rolling out into this uncharted territory. But China didn't stop there. They had an even more ambitious goal in mind: to bring a sample from the far side back to Earth, something that had never been done before. Enter Chang'e 6, the mission that would push the limits of modern space exploration. It wasn't just about landing, it was about collecting, analyzing, and understanding what secrets that hidden half of the moon might hold. And with that, the stage was set. Exploring the far side was only the beginning. China's bold endeavor moved from imaging to landing, and now, the next step was bringing a piece of this mysterious alien landscape back to Earth. But they weren't in it for the fame. This mission promised discoveries that could change what we know about the moon, and maybe even the history of our solar system. The Chang'e 6 mission, a scientific breakthrough. Imagine having to design a spacecraft capable of landing in one of the most unexplored and rugged terrains in the solar system, a place where no direct communication with Earth is even possible. That was the challenge China faced with the Chang'e 6 mission, arguably the most ambitious step in their space program yet. This wasn't just about landing on the moon again. It was about landing on the far side, collecting precious lunar samples from an untouched environment and bringing them back to Earth, a feat no nation had ever achieved. The Chang'e 6 mission is now considered the centerpiece of China's lunar ambitions, and for good reason. While previous missions in the Chang'e program laid the groundwork, Chang'e 6 elevated the stakes. Its primary goal was simple to state, but far harder to execute: retrieve samples from the enigmatic far side of the moon. Why is this such a big deal? Unlike the near side, where Apollo missions landed long ago, the far side remains vastly unexplored. The samples here offer scientists a unique chance to study an area shielded from earthly influences. But this level of exploration came with unprecedented hurdles. Landing on the far side is entirely different from landing on the near side. For starters, the moon's far side is a maze of sharp craters and rocky highlands, areas that complicate safe landings. This means the spacecraft's precision engineering had to be flawless, with systems capable of autonomously navigating this treacherous landscape. But the obstacle of communication might have been an even bigger challenge. Since the far side is perpetually out of direct view from Earth, there's no clear line of sight for sending or receiving signals. In other words, without additional intervention, mission control on Earth would have been flying blind. To solve this, China deployed a relay satellite called Queqiao, a marvel of engineering in its own right. Positioned at a stable point in space beyond the moon, the satellite acted as a middleman, pinging messages between the Chang'e 6 lander and Earth. This satellite not only supported communications, but also ensured that critical mission, data, commands, and eventual findings made it back from the far side in near real time. Without Queqiao, any exploration of the far side at this level would have been impossible. It was this kind of planning, thinking beyond the immediate problem, that allowed Chang'e 6 to overcome challenges no other mission had faced before. The spacecraft itself wasn't just a lander, it was a sophisticated robotic system designed specifically for this mission. Chang'e 6 included advanced tools to drill deep into the lunar regolith, collect materials, and store them for safe transport back to Earth. These systems weren't adapted from older missions. They were built specifically with the far side in mind. Scientists knew they couldn't rely on assumptions about the terrain, so everything had to be equipped to handle unpredictability, from how the soil would respond to drilling to ensuring the samples remained uncontaminated. But why go through all this trouble for lunar dirt? The far side of the moon is a scientific treasure chest. Unlike the near side, which has been shaped by volcanic activity, the far side has remained geologically more pristine, preserving a record of the moon's earliest days. The samples collected here could hold clues about the moon's internal composition and even give us critical insight into its volcanic past. This isn't just about lunar history. It's about understanding the forces that shaped not only the moon, but also the Earth and the solar system as a whole. One particularly exciting possibility is using these samples to refine our understanding of the Big Splash theory, the idea that the moon formed when a Mars-sized object collided with early Earth. Material from the far side could reveal whether this theory holds up or if we need to rethink our models of planetary formation. China's Chang'e 6 mission didn't just answer long-standing questions about the moon's far side. It opened entirely new avenues of inquiry. Each sample transported back to Earth has begun reshaping our understanding of lunar history, while also challenging widely accepted theories like the Big Splash. But this is more than just science. It's a pivotal step toward China's ambitions for a long-term lunar presence. What else might still be hidden beneath the far side's rugged surface? And how long will it take before humanity unlocks those secrets? One thing is certain. The moon's mysteries are far from over, and the competition is accelerating. Share your thoughts in the comments below, and don't forget to subscribe for more updates. Thanks for watching. See you in the next one.